everyone. Welcome and thank you for joining today's webinar, Bring DevOps to Your Databricks Data Warehouse. We are so excited to have you here today. Let's go over a couple housekeeping items before we get started. So questions are welcome throughout the webinar, and we ask that you post those in the Q&A panel, and we will get to those at the end of the presentation. The panelists are so excited to be here. We'll be recording today's session and we will send it via email to you tomorrow to be able to watch again or share with interested colleagues. I'm so excited to introduce our speakers here today. First, we have Cody Davis, who is a Senior Solutions Architect at Databricks, focusing on digital native business strategic accounts and building out the Lakehouse ecosystem. Beyond his professional role, Cody is an avid advocate for data-driven organizations, an investor, fosters animals, and loves music, comedy, and philosophy. Welcome, Cody. Thanks for joining us. And we also have Kevin Chappell joining us today, our VP of Strategic Partnerships. And with over 10 years of experience at Liquibase, Kevin has held many leadership roles within the company, starting with a VP of Engineering to pioneering Liquibase's customer success team. Kevin is now the VP of Strategic Partnerships, where he focuses on driving growth and innovation through our partnerships. We've got some great stuff to go over today. We're going to start with an intro to Liquibase, then we'll go into a history of Databricks, an awesome live demo that Cody's going to do for you all, and then we'll end with a Q&A to answer any questions that you have. All right, so before we dive in, we thought that we would get ourselves warmed up with the first quick poll. So I'm going to go ahead and launch that here. We'd like to know which phase best aligns with your organization's DevOps maturity. So let's see, we've got initial, that's like a traditional environment with dev and ops separate. Then we get into like more of a managed maturity level. You're in beginning stages, focused on agility with initial automation. Or are you more in a defined stage? You've got org-wide transformation beginning with your defined process. And then we've got measured, that your process and automation with continuous improvement, or you optimized, achievements are visible and team gaps disappear. So just a couple more seconds for everyone to lock in their answers and we'll see what we got. All right, let's see. Okay, so it looks like about 40% of us are in that measured category. And then we've got kind of a tie for second across initial, managed, and defined. That's great. Thank you for that. And I'm going to go ahead and stop sharing. And over to you, Kevin.
All right, Shay, thank you. There we go. All right, Shay, thank you very much for that. I want to first talk about why we built Liquibase. Application teams have increasingly automated their software development process. This means that they've created a hands-off environment where they can commit code changes to source control and feel confident that their software is getting built, packaged, tested, and deployed in a consistent manner. This automation and validation helps ensure high-quality releases and fast cycle times. Unfortunately, the corresponding database changes are often still reviewed and deployed manually, separately, typically by a separate team. This lack of automation and consistency increases the chance of errors and slows application development. First, Liquibase helps teams automate their database changes alongside their code to increase the velocity of change. Then, Liquibase adds database change validation to ensure that changes are made faster and safely, resulting in high-quality releases. With database changes centralized and managed consistently, companies gain governance and auditability of database changes throughout the development lifecycle. Liquibase also brings visibility into a previously invisible process. Through standard reports and structured logging that integrate into enterprise observability tools like Splunk, Datadog, and Elasticsearch, teams now have turnkey and custom dashboard visibility into database change management throughout their organization. Liquibase integrates easily with popular source control, DevOps automation platforms, and observability tools. Liquibase also supports over 60 databases to ensure everyone can use the same database change management solution regardless of the data store a team decides to use. Let's stop for a quick poll. What's your biggest hurdle to DevOps adoption? Wow, looks like it's pretty evenly split. We have a just by a bit, budget wins out as the biggest hurdle, followed by lack of ownership and lack of app dev support. And then the last three, kind of the trailing three, is lack of prioritization, lack of DBA support, and lack of clear first steps. So it sounds like people are really struggling with budget. All right. As mentioned on a previous slide, Liquibase has broad and deep support for over 60 databases, from relational databases and data warehouses to a variety of NoSQL data stores, including document, key value, wide column, and graph data stores. Databricks is our newest addition, and Cody will take us through an overview and demo of Databricks and Liquibase.
Awesome. Thank you, Kevin. I will take on the screen here. And I'm going to apologize in advance just in case, because I'm getting over a cold and have a little cough, but I'll try to contain it. Kevin, can you let me know if you can see my slides?
They look great.
Awesome. So I'm assuming not everyone's familiar with Databricks. So before we get into the Liquibase and Databricks integration and connector, I first want to define a little bit what Databricks is, what its goal is, and sort of the kind of rich capabilities of our data warehousing products in particular. So for those that are new to the company, don't really know much about it, Databricks is the data and AI company founded by the creators of Delta Lake, MLflow, Apache Spark, and Mosaic MPT, all amazing open source projects. Started over 10 years ago, we've grown to over 10,000 global customers, 1.5 billion in revenue, and are now a leader, globally recognized leader in both data science and analytics, and also database management systems. One of the only companies to be recognized as a leader in both. So what Databricks has done is been able to take these open source technologies and use them as the foundation for a broader unified data analytics platform. So what does that mean? Well, our hypothesis has and always has been for the last 10 plus years that the winners in every industry will be companies that use data and AI together seamlessly. And that's much easier said than done. In reality, most organizations have a really hard time doing this because with existing technology today, you have to stitch together many, many disparate technologies for data ingestion, transformation, BI, advanced ML, and then now generative AI. So in reality, all of these different pieces of the data stack are all completely different technologies, and most importantly, with a completely separate governance model and even actual underlying data model as well. So that makes for very, very difficult to manage, scale, control, and govern your kind of unified data stack that's not really unified today. Most importantly, having a data stack across, streaming, ingestion, ML, BI, et cetera, is dependent on highly technical staff with a lot of brittle failure points in the stack. So this is what Databricks aims to solve with the Databricks, the data lakehouse. So what the lakehouse is built on top of Spark in Delta Lake and now Delta Lake Uniform. We have enabled a unified governance layer called Unity Catalog that you'll see in action today. And with this foundation, we're able to create products that use the same underlying technology and actually create a unified single pane of glass for all of your end-to-end data stack. And this kind of never before seen platform is what enables businesses to do BI and AI seamlessly all together with one tool. So currently, Databricks pioneered the Lakehouse just a little over 3 years ago, and now 74% of CIOs and enterprises have adopted the Lakehouse today, and the rest are planning on adopting it in the next 3 years. So zooming in specifically to this data warehousing piece, this is what we're going to talk a lot about today because this is what Liquibase integrates perfectly with and what the connector is all about. So Databricks SQL is a part of the Lakehouse that is a data warehousing, a cloud-native data warehouse that's instant, serverless, and fully elastic that operates on data in your own Lakehouse directly on top of your data and storage layer. So this completely separates compute from storage and allows you to leave your data where you want it to live. You don't have to put everything into a proprietary data warehouse to get the best in industry performance, all in an open table format. And of course, most importantly, Databricks SQL utilizes and is built directly with the Unity catalog to govern all data assets. And it has a rich end-to-end orchestration layer that allows you to orchestrate and manage any workflow on top of Databricks SQL. And if you have existing tools from Databricks SQL, then you can, of course, use those as well, as Databricks integrates with the existing rich data warehousing ecosystem like dbt, Power BI, and now, of course, Liquibase. And most importantly, where we're heading in the future and where we've been for years, Databricks SQL integrates and embeds AI out of the box. So you'll see this a little bit today, but not only can you use AI in SQL out of the box, you can also add your own custom models with virtually no limits on what you can do with AI and BI together, all with one serverless engine. So double-clicking into a couple aspects of Databricks SQL that I think are really important for this Liquibase integration here is, of course, that unified governance layer. So that's a pretty general, broad term. So I want to kind of highlight what specifically that means. With Databricks SQL and Databricks Unity Catalog working together, you can seamlessly govern, access, and collaborate on all of your end-to-end data and AI assets and get automated end-to-end lineage on those assets. So you can see here, you can stitch together your tables, federated data sources, columns, and more, all automated out of the box. And not only that, can you do that for tables? You can also govern raw data, models, functions, federated connections, and even data sharing in one specific place, all with the same access control model. So this is that kind of unprecedented, never before seen unified catalog that really is the bedrock for how the data lakehouse and data intelligence platform will run today. And this is one of my favorite things about Databricks SQL is, and Databricks in general, is that you can orchestrate your SQL queries, dashboards, alerts, models, and more, all with the native workflows orchestration tool that Databricks offers out of the box at no additional charge. So typically free products are, not great, but in my opinion, Databricks has the most mature orchestration framework, and it doesn't charge extra for it. It's just part of the product. And that really, really helps, one, have a lot of control over how you orchestrate your workloads, but also really, really great visibility into those workloads as well. However, many customers, many users have existing tools like dbt, Airflow, etc. Of course, we integrate with all of those existing technologies today. So we're not a this or that company. It's a yes and on Databricks. You can use any tool you need to run your data lake house for all your teams. And of course, because Databricks SQL is built with that unified governance layer, your AI, your data tables, everything is governed, managed, and stored in one place. This allows you to bring the best of the data lake and warehouse together to go from BI to AI seamlessly, all in the same product and even in the same line of SQL code. So this is an example of being able to use AI functions directly in SQL. And if you want to go further than that, build your own models, you can do that in the same Databricks product and register and use those in SQL as well. So this is a very, very quick 5-minute summary of how we go from sort of basic BI and data warehousing and take that many steps farther by integrating completely serverless elastic compute and seamlessly integrating AI to that as well. So let's double click into sort of why we're here, kind of database change management. Not only is Databricks SQL, innovating on the AI and data governance front, but we also offer plenty of existing toolings that are going to look and feel very familiar, and they're going to feel actually even nicer to database administrators and database managers. So Databricks SQL has a really rich integrated query history and profiling tab to allow you to monitor your warehouses and also kind of troubleshoot and do query planning and analysis directly in the product. And so if you've ever used kind of any data warehouse, you'll know that query planning, query tuning, troubleshooting can get complicated. It's not always super easy to do. The query profile makes that ridiculously simple compared to a lot of these other platforms. I use it every day. It's much better than using kind of the old school Spark UI. And of course, data warehouse isn't complete without, data modeling. And so Databricks offers the classic kind of table constraints like primary and foreign key constraints, identity columns, and also data quality check constraints as well. And natively in Unity Catalog, you can now pull up your ERD relationship diagram of your tables directly in the platform. And lastly, and this is what we're going to kind of focus on and build on top of today, Databricks SQL now, now has system tables that allow you to get all of that standard information that you're used to getting and require to do proper database change management and governance on your tables. So not only do we have the classic information schema, but we're also rolling out new system tables every day. We have a lot of system tables already, from billing, compute, audit event logging, warehouse history, and many more to come. So this is kind of the segue into what Liquibase, the Databricks Liquibase connector is built on top of. So with that, we're actually going to show the product or the connector and go through a small example of just developing some stuff in a development database using Liquibase to take a snapshot of that development database, reviewing the changes, excuse me, and then promoting those changes to a new production database. And then we're going to basically build that feedback loop, that kind of change deployment feedback loop there with this demo today. So we'll go through some of the steps and you'll get to see kind of Liquibase in action. But I also have included a Git repo of this demo. So if you want to play around with this design pattern here, you can use this Git repo and reproduce it yourself if you'd like. So with that, let's jump into Databricks. And Kevin, just checking, can you see my Databricks screen?
Yes, I can. It looks great.
All right. So in Databricks, before we go into the specific use case, Databricks is a pretty large platform, has a lot of capabilities. This is the home screen when you log in. It's navigated via this workspace bar here. So you can see that we have general kind of workspace, catalog, workflows, and compute. And we have kind of personified individual groupings of the platform. So for data engineers, if you want to write Python, Scala, SQL code in end-to-end pipelines, you can do all that here. If you're building models, doing feature engineering, serving models, playing with LLMs, you can do all of that here in the machine learning tab. And then what we'll focus on today is the sort of data warehousing portion. If you want to do just the data warehousing piece of Databricks, these are the pieces that lets you spin up a serverless SQL data warehouse, access your query history, build dashboards and alerts on top of that and schedule them. And of course, access a very rich SQL editor that we'll see next. So with that, what a user would typically do to start up a demo is go into the warehouse tab, create some compute, pick a t-shirt size, and pick how you want to auto scale, and then choose serverless pro or classic, and then name your warehouse. And that's really it. And then offer access to it. So once we have a warehouse created, which we already do, then we can start to do stuff in our development environment. So taking all of these pieces here, generally the first thing we want to do is access our data catalog, because this is where the data is going to be organized. This is our Unity catalog, where everything lives, whether it's models, functions, what have you. So I've ahead of time created two schemas, two databases. And what we're going to do is create a dev database, make some changes, do some stuff, use Liquibase to deploy those changes into a separate production prod database. So this is the catalog view of my dev database. I can add tags, comments. I can use directly with BI tools. I can look at my tables. I can look at my volumes, which is storing, managing underlying raw source data. So this is all integrated in the same governance layer. I can store, manage, access, and serve my models. And I can also create custom functions, whether it's Python, SQL, what have you, and store them in Unity Catalog as well, and govern those all in the same way. So from there, I can click on a table, click on my bronze sensors table here that we've created. And I can get a lot more intelligence around, how big the table is, how many files, how popular. AI is going to try to understand the semantics of what this table is doing and try to add some metadata and comments around it. And you can kind of accept or reject that. And then, of course, you can look at your details, history, and now lineage. So lineage, we've created brand new tables, so we don't have any lineage yet, but this is where you can access sort of the end-to-end data lineage of your pipelines. So, okay, let's jump into the actual Liquibase workflow. So let's say I'm a developer. I'm in the, excuse me, SQL editor here in my Databricks SQL workspace. And I'm just going to pretend I'm developing something from scratch. I'm going to create a couple tables, using the classic Databricks bronze, silver, gold medallion architecture. That's a fancy term for just saying we have kind of staging tables, and then we have modeled tables, and then we have kind of BI aggregate tables for more kind of business level aggregations. So I'll create a staging bronze sensors table, create another staging bronze layer for user data. Well, let's pretend this is like Apple Watch data. We're ingesting some of that. And then maybe we merge upsert into a silver zone, where that's kind of like our core modeled zone where users are going to actually build applications off of. And then maybe I have some more rich aggregations I want to do downstream. So maybe I want to have some hourly summary statistics that are kind of recreated, or with a materialized view, we can create that as well. And then I have a more sophisticated view that I want to build. So I've typed this up in my development environment. And now I want to essentially, test and promote this to production. So I've defined these tables in my development environment. Let's assume I've run this code. Well, then what I would do is go over to Liquibase, and I would run Liquibase generate changelog, and that will take a snapshot of my development environment. But before we go through that workflow, let's kind of talk about how this is structured here. So to create that feedback loop between dev and production that I showed in the original slide before we did the demo, what you'll do is you'll create a dev Liquibase properties file that points to your dev database and outputs a dev changelog. And then you'll create a production version of that. And the production version of that points to your production database. And in addition, it will also have the reference database. So reference URL, reference, location, username, password. And so what that does is allow you to have your production environment refer to dev to take incremental snapshots and basically keep your production changelog up to date. So now that we have these two set up, we can run Liquibase generate changelog on our dev profile. And I've already run a lot of these, but we'll run a couple things just to kind of show how Liquibase works. And once we run our dev generate changelog, that will create this changelog for us. So if we're starting a new project, we don't have to code this up all from scratch. We can just take a snapshot and then incrementally develop and manage our environment from there. So a lot of new users to Liquibase ask me, like, I don't know, XML, or I don't know how to do this from scratch. You don't have to. So this took a snapshot of our tables. So it gave us the data model. It even gave us the view definition. And so we have essentially what we want. So now we can decide a couple things. We can take a Liquibase generate diff changelog, and that will take a snapshot of the difference between production and dev. And right now our production database would be empty if we're starting. And that will create our production changelog. And that'll be the incremental difference between our two environments. And this is where we want to start adding maybe some custom things. So there's a lot of things that the Databricks connector has capabilities for that are Databricks specific. So maybe we don't just want the table, the table data model here. We can also add our indexing columns. So we call those our cluster columns in Databricks with liquid clustering. We can add that option here in our table. And we can also do other maintenance operations like optimize our tables. This kind of refreshes our file layout. We can vacuum tables, things like that. And we can use preconditions and other Liquibase options to essentially say, hey, run this every time we do a database deployment, just to keep our tables healthy and up to date. So we're starting to get a little bit more fancy with what we're doing, starting to customize our kind of production change environment. So that way, every time a bronze table, every time this changelog is run, this will always optimize the bronze sensors table. And we'll kind of see that in action once we actually run a change command. We can also optimize our underlying change lock tables if we want, just kind of an example of that, and include that run always parameter if we want it to run every time we do a deployment. And then we can get even fancier. So we can create, our other silver users tables. We can add clustering columns to those as well. But we can also create dependencies. So the most common need for this is if you have views, especially nested views. It's a pretty common design pattern for like that gold aggregate layer. You can create a view that runs every time you see a change in the underlying definition. You can add this replace if exists functionality. And you can basically set a precondition. So if your view is based off of another view or table, you can create that dependency with preconditions here based off of your change set. So out of the box with the Liquibase Databricks connector, you can already do some pretty fancy stuff. And now all we would do at this point, once we reviewed our changes, is run that Liquibase update command at the bottom here. And I've already ran this a few times, so you can see that we run quite a few changes. And so our production environment is no longer blank. It is now in sync with our development environment. So then the last thing we'd want to do is actually add some more changes and see what happens. So let's actually do that. So I can go down here. I've already added, a bunch of columns. I can, in my development environment, maybe we add a column. Let's call it a string, something simple. And we can run that. Oh, need my environment. Okay. Oh, that's my typo. Cool. So now we've changed our model in dev. And so we don't want to have to manually figure out what's changed when we do deployments. So now we can use that Liquibase example here and take let's go back. We want to run our Liquibase diff changelog command. And so pay attention to this, this production changelog here. Once we run this, the command is running. And what this is doing is taking an incremental snapshot of our Databricks environment. So I'll show you in the query history. You can see Liquibase running in real time with this query history tab. You can click on refresh, and you can see it taking a snapshot of things. So it's getting the data model, kind of traversing everything that exists in the schema, trying to figure out what's different. All right, so now we've executed the diff changelog command successfully. And now if we refresh this, oh, it added, but my browser's not refreshing. Come on. Okay, there it goes. So we added our new column. And so now that we have our new column, all we need to do is run Liquibase update to incrementally update our production environment. So now we're running Liquibase update. Let's go over to Databricks and watch it run. So it's doing a kind of transaction change. All right, a couple things here. So because we enabled that optimize command to run always with that parameter, we see that's what it's doing. It's optimizing our database table here. And so now we can be rest assured and confirm that this does indeed run every time we ask it to. So that's good. All right, and so now we see here is the change that we asked it to deploy incrementally. So we can see here that it's altered our table and we're now good to go here. And that's essentially the workflow. So you can continue to add to this feedback loop and keep the databases up to date. And then in your Catalog Explorer, we have not done any manual intervention to our production environment. And so all we have to do to check and make sure all our changes are in sync is go to our production environment and see that all of our tables are indeed up to date. And we can check on our silver sensors table. We have all our new columns that we've deployed incrementally without ever manually touching production, which is exactly what we want. And our environments are now in sync. So really, really powerful capabilities with this design pattern. A couple things, and that's generally the workflow. Before we pass it back over to Kevin, I do want to also highlight that the Databricks, Liquibase Databricks connector also allows and automatically creates the right type of Delta table and configuration for data warehousing workloads. So Delta tables are kind of a superset. They can do data warehousing, and they can also do a lot more stuff for much, much larger data sets and other kind of use cases. So if you look at a create table and you create tables with the Liquibase connector, here's what it will generate. Oh, where did we go? It's somewhere else over here. Okay, I did it wrong at some point. Well, if you use the Liquibase connector, then it should be creating tables that are automatically configured in the right way with the data warehousing things enabled, like change data feed, column name mappings, etc. And so that's essentially the workflow. So if you want to practice with the Liquibase kind of the example workflow and demo, then I actually created this repo that you can use to recreate this simple workflow to kind of get used to the connector and explore. And overall, I think that's really it. So Kevin, I'll pass it back to you to finish up a couple slides on kind of the future of Liquibase and what Liquibase is doing next, and then we can go ahead and answer any questions and start a Q&A.
That's great, Cody. I love that workflow. It's very comfortable for a developer to be able to work in the tools, capture the changes, and then I love that extra component at the end where you can take the changes and you can really layer in administrative things so you don't forget them or do them, forget to do them manually later or do them differently in different environments. Or I think that's a very nice workflow. I think it's helpful. Let me share my screen back. All right, can you see that?
Yes.
Okay. So as Cody ran his database deployments, Liquibase captures information about his database operations in the background. This information feeds a customer's observability dashboard, giving teams visibility into their change management pipeline. With this information, teams can quickly identify the root cause of problems and gain visibility into operational metrics to help teams increase their effectiveness over time. I want to share a quick example of how this can improve team performance. So using these observability metrics, a Liquibase customer was able to measure and see improvements in their database DevOps operations. After Liquibase, they were deploying 3 times as frequently as they had in the past. Their change failure rate declined by 95%, and their lead time was reduced by 94%. And instead of MTTR, another very common DORA metric, this team wanted to measure batch size to encourage smaller increments that could be released more frequently, and their batch size was reduced by 60%. So just a little bit of insight into how Liquibase behind the covers gathers a lot of information, brings it together, and provides your team with insights into what's going on in the background. Now I'd like to turn this over to Shay for Q&A.
Wonderful. Thank you, Cody. Thank you, Kevin. So yes, the last portion of this will be our live Q&A. I already see some great questions that have been submitted. If you have not submitted your question yet, go ahead and put that in the Q&A panel, and we'll get to as many as we can in the last few minutes that we have. So let's dive in. Our first question. On the SQL warehouse, let's see. Okay, let's do this question. Are there change controls which can be enabled during this process before the prod sync happens from a reference dev environment?
Which one of us should take that one, Cody? I mean,
Yeah.
they're definitely you can put in whatever controls make sense for your company. I think Cody really optimized for a developer experience, but certainly you want to have more audit and control in place in a production environment, and you can certainly do that with your tooling. And Liquibase also has policy checks that can be inserted in the process to make sure that things are well formed and things are done in the proper order before deployments.
Wonderful. Okay, next question. How does this tie to Git?
As Cody's in the process of typing the answer, I also want to point out, Shay, that there are 4 answered questions on the answered tab that we might want to also go through.
Yeah, let's do that. Okay, how about, let's go ahead and go through some of the answered questions.
So
Awesome.
let's go ahead and I'll go ahead and read the question, and then maybe since you answered them, Cody, you can answer.
No
So
problem.
one is curious, is Databricks UC integration for Liquibase available for Community Edition, or is it only available for Pro? I guess I could even answer that too. The connector is completely open source, and it is available to both the open source Community Edition and the Pro Edition of Liquibase. All
Absolutely.
right.
And the Unity catalog question. So Unity catalog is required to use the Liquibase connector because Unity catalog has all the system tables and metadata around it that you would expect out of a typical data warehouse. Hive Metastore does not have these capabilities. So this is part of the reason why Databricks invented the Unity catalog. In addition to the sort of unified governance, it's also to kind of catch up and move beyond the capability limitations of Hive Metastore.
All right. And then Siva asked, on the SQL warehouse, I would assume that Liquibase will work for serverless and the standard warehouse. Also, will the warehouse wake up automatically if it's in terminated state?
Yep, the warehouse will indeed wake up automatically, and you do not need to use serverless. So it can technically work for any cluster as long as you're using Unity Catalog.
Nice.
But if you use Databricks SQL, that's going to get you that kind of beautiful, really nice query history that has the query profile and all that. So that's kind of the incentive, is that everything is kind of right there and easy to track.
Excellent. And I guess we answered, let's see. And how does this tie to Git?
Yeah, so big question. Essentially, what Liquibase does this really well for its own connectors, but you can essentially automate all of this process that we just went through with Git actions. So you can do kind of pull request notifications and unit testing frameworks to do unit and integration testing frameworks to kind of automate all this. But that starts to become more tailored to how you want to deploy things in your organization. So yeah, I think you should absolutely reach out to us if you're trying to figure out the exact architecture and design that you want to implement with Databricks and Liquibase. We'd be happy to help you design that.
That's great. Is there a certain version of Liquibase we at least need to use this?
Yep. So the newest version is 1.1.3 for the connector, and then I think the connector is also on the newest
4.26.0. You're correct.
Yep.
Perfect.
Yep. So yeah, those new versions, definitely use those. There will be new versions that come out, roughly every month or every other month for the connector. We'll be adding new things like, customizing table properties and things like that. But you should have everything you need now to kind of use this in production. So yeah, I think we can send out those slides if it's okay with you, Kevin. I think that's something we can definitely do.
Yes. That will be included in tomorrow's email. You'll have a recording of today as well as a version of the slides.
Awesome. And can we have that workflow for views? Absolutely. So that workflow for views includes that sort of modification trigger. So if you go to that GitHub link in the slides that has the demo content, that's the exact workflow you're looking for. You'll be able to see how that works. But basically with preconditions and run on change, it'll sort of update, create, or replace the view as the definition changes.
All right. There's a question here about I'm having connectivity failure using Databricks connector. Can we can we shred some environmental setup? But basically, can they get help with environmental setup? I would say that in the information we're going to send, there is a Liquibase Databricks tutorial that goes into a very much more detailed step-by-step with troubleshooting steps for getting it set up with a very simple use case, just to make sure everything's connected and working well. We'll send that out when we send out the slides and the rest of the information that Shay's going to send. And if you have questions on that page, there's a feedback button. So feel free to click that. If you still get stuck or you still have problems, I watch that all the time. And I can reach out to you directly for your email. And I'll also make sure that page gets updated with any specific things that you're saying so we can continue to build out our troubleshooting section.
All right. So I think this question around Liquibase and DBT in parallel is an interesting one, and we should talk offline about this to kind of cover some details. But they kind of have two different philosophies, right? So this is why Databricks, this is kind of the original Databricks perspective in big data, was that schema should be flexible and schema on read. So basically automatically merge and evolve the schema. And that's sort of what DBT does as well. It's very schema on read. The schema is based on the actual select statements that are put in there. However, in Liquibase, this was built more for the kind of the BI side and the application development side. So that has a different school of thought with schema management, and it being more rigid, because applications need to know what their data models are under the hood. You can't just automatically evolve schemas when you have data applications and reports built on top of them. So while it's technically possible to use them in parallel, we should really think critically and specifically around like what the workflows are in DBT and how you manage schemas in those environments. So I definitely recommend reaching out to us so we can help design that with you, because they do, operate from different schools of thought with schema management. But it is technically possible. Just need to be careful and think through it.
So there's a question: can this be made available in Liquibase Enterprise as well? Right now, it's currently only available in the open source and pro versions, but I would say contact us directly and let's have a conversation about that. I see Biswa here has a comment: can't find driver, etc. Going back to that getting started tutorial I mentioned earlier, we'll send that out. It has very detailed, very explicit instructions on the links to click and how to download and where to put your drivers and your extension. So it makes it easier to get everything set up.
Yeah, and we also have, we have a lot of content around data warehousing in general on Databricks SQL, and included in that is, Liquibase setup and design pattern blogs that we've already published. So I'll actually put that link in the slides to our Databricks SQL SME engineering publication that you can use to sort of learn about how to use Databricks SQL more.
Yeah, and Cody, I also put those two links at the end of the tutorial, so people have that further information, because you go into a lot more detail about more advanced use cases and things that I really am not covering in the Getting Started guide. So I think it's really, both of those articles, Medium articles, are fantastic. I use them to learn Databricks. I did great. So I definitely encourage y'all to go dig into those as well.
Awesome.
Yep. And the version of Liquibase, depending on what version of the connector you have for Databricks, you need the appropriate version of Liquibase. I would say just go to the latest version of Liquibase and the latest version of the connector, and you'll be fine. So it's 1.1.3, I think, Cody, for the connector, and 4.26.0 for Liquibase.
Absolutely.
Yep.
All right, I added the blog publication to the slides, so when we send that out, you should have access to that.
Excellent. Now I've lost track of where we were in the questions. Do you see the next one?
Some of them are, excuse me, some of them are around can't find driver. Check out that tutorial, reach out to us if you still can't figure it out. We'll help you troubleshoot. Are we limiting the reference DB concept to maintain metadata? So no, the concepts are the same. You can use a different Liquibase reference database. So by default, I think you saw in the demo that the kind of tracking tables, changelog and changelog tables, are in the same database in which the changes are being deployed, but that doesn't necessarily need to be the case. So you can customize that just like you would any other database. And then on the users, roles, and groups, right now, Liquibase is focused on sort of the data assets. So I think that got deleted there, but Liquibase is focused on the data assets. So for users, roles, and groups that can be scripted, the kind of de facto way we've done that in the past is via Terraform. So when you want to orchestrate sort of infrastructure and access policies, Terraform is a really great way to do that. And reach out to me. I can help you point out to some pretty easy solution accelerators to get you started there.
Yeah, and Cody, we do the exact same thing here at Liquibase. We use Terraform for that part of the process.
Terraform is really, really great for kind of infrastructure and compute. It's really challenging, not necessarily for data assets, which is why Liquibase is the de facto solution there. But
Wonderful. All really, really great questions. Thank you all. And if you weren't able to get the answer or the follow-up that you needed, we can contact you directly after offline and make sure we get all your questions answered. So with that, let's go ahead and kick to our last slide. We just want to thank you all for joining us today. Some next steps, connect with us on LinkedIn. Cody and Kevin would love to connect with you and learn more about your use cases and what your challenges are and how we can help you address those. Contribute on GitHub. You can see the link here for the Liquibase Databricks GitHub, and check out the demo repo that Cody's created for us. You can see that link here as well. Really a great next step to get hands-on yourself is to start a 30-day free trial of Liquibase Pro. So you can see that QR code here to get started there as well. And we'll be excited to help guide you through that. So with that, Kevin, Cody, thank you so much for your wonderful presentation and your demo today. Thank you all for who attended, and we hope you have a great rest of your day.
Awesome. Thank you all.
Thank you. Thank you, Shay. Thank you.
Bye-bye.
Bye.